All right. Well, thank you again for joining us. I am your host, Taryn Picard. I'm the Global Product Marketing Manager here at Onsa Computer. I've been working with HOBO data loggers for over 9 years now. And I just love our HOBO loggers, and I love hearing about the adventures they go on and all the different projects they get to help with. So I'm very excited today to be listening in on how our loggers have been helping with testing and the development of temperature regulating building products. A little bit about Onset. So who we are and what we do. We are the home of the HOBO data loggers. In that picture right there, which is actually our facility located in Massachusetts on Cape Cod, we do all of our designing and manufacturing of our data loggers. Very proud to be a US-based company, and I'll also support streamlining processes, and we really try to do things as efficiently and effectively as possible. So we're ISO 9001, 2000 certified. And we have a global network of distributors. So our data loggers are used around the world to support all different types of applications. So today's presenter, I'm very pleased to announce Dr. Matt Aguayo will be joining us today. He is the co-founder and CEO of EnKoat, which is an advanced material company focused on designing building performance products and coatings that make buildings more energy efficient. Dr. Aguayo is, received his Ph.D. in structures and materials engineering from Arizona State University and was featured in Forbes 30 Under 30 for energy. With that, take it away.
Awesome. Thank you, Taryn. I appreciate it. Yeah, everyone, excited to be here. Let's get center mode. Awesome. So yeah, thank you everybody for joining me today. I'm really excited to, start this day off here in Arizona is where I'm located. It's about 107 as the high today, gonna reach 112. So perfect presentation to show you what exactly we're accomplishing at EnKoat. So I want to make sure that we'll talk about data loggers and how we're using them, but I really want to tell you like our story at EnKoat, like what's the motivation behind what we're doing and the impact we're ultimately going to achieve. So I have a brief outline of what we'll be talking about. So I'll start, who's EnKoat? Where did we, get our start? Why are we doing this? The motivation. Then I'll talk more about the innovation. What is it exactly that we've developed that we're revolutionizing building products with? Then when we get to the prototyping, lab scale, and field scale sections, that's when we'll really get into how we used HOBO data loggers to help us, just advance to the next stage in that product development. And then our roadmap will give you a snapshot of where our products start and ultimately where our products are going to finish. And I'll wrap everything up by, what is the impact our technology can make at scale within the built environment. So about EnKoat, we are an advanced materials company headquartered here in Phoenix, Arizona. And our mission is to decarbonize the built environment for a sustainable future. And the only way we're able to do that is by looking at one building at a time. And we're transforming traditional building products that go on buildings, whether that's wall panels, paint, I'll get into more of that later, but we're turning them into advanced thermal management solutions. Ashay and I were both co-founders of EnKoat. We started this journey back in 2018. So we saw all of our peers graduating and going into industry, and all of the research and cool, exciting projects that they were working on, they just stayed back at grad school. But us, we thought, well, we've been working on things that can truly, revolutionize the built environment from a material point of view. Let's see where we can take this. So we founded the company in 2018. We graduated with our PhDs that same year. And from then we've done the whole startup scene, both at the local level with pitch competitions, national level pitch competitions. And what a journey we've had talking to all kinds of stakeholders to really get an idea of, what does the landscape look like for new building products, and what is it that every stakeholder throughout the value chain, whether it's, a raw material supplier, it's a building developer, it's a contractor, what are their pain points that we can, ultimately solve? So with that, let's see where it all began. Both of us grad students in college, we went to Arizona State University, and the material that we were working with was concrete. And I know, like, I get it all the time, like, concrete, isn't that just, a pavement or a sidewalk? But it turns out concrete's actually one of the most complex materials on the planet. It's the second most widely used material on the planet, the first being water. And what we did was we looked at these systems both from the chemistry and physics point of view on like a micro scale, and we scaled it all the way up to actual structures. So the image you see on the left, typical concrete layer that's subjected to these same external environment conditions that a building's subjected to. You have different heat properties or transfer properties like convection, radiation, conduction, and what that concrete layer is doing is ultimately protecting the subbase or the base underneath. Now, for this particular application, we were looking at how do you manage thermal cracking and freeze thaw in concrete. Those are two big durability issues, both of which, if solved, could extend the service life of pavements, of bridges, of buildings. And this is really where we started to focus in on the technology that we were developing and how we can scale it to different applications. So we've been using temperature loggers since the beginning. So the image you see on the top, that's of two pavement sections. We always, when we test or develop a new product, we compare it against a control. And these are temperature loggers as well as strain sensors. So what we wanted to do was, what is the temperature these concretes are being subjected to? Like, how much of a reduction could we achieve? And ultimately, how much less movement of these pavements can we expect? And this was placed in Arizona, so we have high, temperatures leads to thermal stresses, thermal cracking. So this is the problem that we were solving. But we thought, you know what? This is such a great technology. Where can we solve an even bigger problem? And that problem comes with buildings. So right now, climate change, it's here, it's happening. That's leading to extreme temperatures. We're talking about heat, but also look at extreme cold temperatures like what's happening in Texas. Whenever extreme temperatures rise or drop below, you have higher energy consumption because your mechanical equipment is having to run more. And this is ultimately leading to higher energy costs. Right now, the US spends over $400 billion annually to heat and cool buildings. And the image you see on the left, this is what our climate looks like currently. So states with, days above 100 degrees, and you'll see Arizona is one of the hottest states. No, go figure. But surprisingly enough, come in the next coming decades, more states are going to resemble Arizona's current climate. So the problem is not going away. It's actually going to get even worse. And so that is the mission and purpose that we have undertaken, which is to solve this problem. But what is our motivation? And these two images sum it up perfectly. On the left, you see residential construction. On the right, commercial construction. So over 100 years, for the past 100 years, we've been building buildings the exact same way. Not only the methods used to make them, but the materials as well. On the left, we're still using timber construction. On the right, those are still structures, but we're also using concrete. And for us, the motivation is, can we turn these existing building products that go into buildings into thermal management solutions? Can we give them an additional functionality, something that, as I'll get into it as far as a paint goes, but paint, we're so used to painting our homes for a specific color, but hey, what if our paint can actually help regulate the temperature inside of our buildings? Now, other people aren't focused on the problem like we are. there's other high performance solutions like thermal mass construction or panel construction, air sealing. Each of these are great at improving the energy efficiency and thermal resilience of the envelope, but they're not mainstream. You don't see much thermal mass construction or panel construction. And the reason being is because builders, just stakeholders in general, they're hesitant to try something new. Even though each of these are great technologies, there's still some hesitation, and each comes with its own benefit. If we look at thermal mass, you use concrete to help mitigate or swing the thermal inertia from inside and outside temperatures. Panelized construction is getting rid of the stick frame construction you saw in the previous picture and having a continuous structure that has continuous insulation. You're lowering the thermal bridging that takes place. And then that gets to air sealing. So I'm sure you drive down the road and you see a new subdivision being built, and you see the foam siding, and then you see the taped seams. So that is all to prevent thermal bridging of, the external heat trying to get into the inside. Well, we decided, let's take our technology and turn traditional products into thermal management solutions, and this is where the innovation comes from. So we'll start out by talking about our adaptive materials technology that we've developed. This plot right here, it pretty much summarizes how the technology affects a building. If you look at the dash line, that represents what you'd set your thermostat to. And then the gray line, that represents what your building is actually subjected to, the daily temperature fluctuation or profile, throughout the day. So this goes for 2 cycles, so about 2 days. Now, when you put our technology into these building products, what's happening is it's actually flattening this curve. It's reducing the temperature and it's shifting that peak temperature. What makes us unique is that we've actually engineered and designed this technology for climate-specific applications. Traditional building products, it's a one solution fits all. You buy one product, here in Arizona, that's likely the same product that you'll buy in New York, whether that's insulation, whether it's OSB sheathing, siding, what have you. But we really figured if we're going to make an impact, our technology needs to be tailored. So the first product that we're commercializing currently is an elastomeric roof paint that we've integrated our adaptive material technology into. This paint, it's been tested, it's proven, and it's cost effective. The ROI is great for the building owner, which I can talk towards more later. But we started with elastomeric roof paint because we wanted to really hit the problem hard and make the biggest impact. And there's so many commercial flat roof buildings that if you put this technology on there, there's so many benefits, not just for the building owner, but for the environment at large. And for those of you who don't know what an elastomeric roof paint is, there's other names for it, like liquid applied membranes, fluid applied systems. But the goal is to place a layer of protection on top of your roof substrate to not only weatherproof your building and roof from the elements, whether that's wind, rain, snow, but also UV protection. Here in Arizona, you see that a lot, where the harsh radiant heat can really eat at the roof substrate, whether you have a asphalt shingle roof, a foam roof. So elastomeric roof paint, it gives your roof an extended life period. So what does that mean for building owners? Well, it means that the temperatures on the roof reduce. That leads to lower utility bills, and then it extends your roof service because it's having that extra layer of protection. You're getting that extended service life, and it also extends the equipment life. Now, to see what the difference is between our technology and current technologies on the market, this plot right, or this graph right here really summarizes it. So you have reflective, and let's talk just solely for paints right now. So reflective paints are great. You've probably heard of cool roofs. What they do is they reflect radiant heat back out and help lower internal temperatures. Insulative paints, a little more expensive, but what they do is they actually reduce that conduction into your building. So reflective may reflect radiant heat, but you still have conductive heat that wants to get into your building. So that's when insulative paints will help. But our adaptive materials technology combines all of these and adds an extra layer coming in the form of thermal energy storage. And for those who don't know, thermal energy storage, the way I like to describe it is when you put ice in an ice chest, it helps keep your drinks cold. Even when the ice is melting, it's still maintaining a specific temperature. What we do is we select the temperature based on a specific climate. So a state like Arizona would have a higher activation temperature than, let's say, a state like New York. We've developed these paints through funding from the National Science Foundation and are receiving validation on the thermal performance from the National Renewable Energy Laboratory. So roof paint is our first product, but this can go in any building product. The higher TRL levels are stucco and plaster because when we develop the roof paint, we develop those as well. But we're also working on wall panels and roof panels for the high performance solutions I mentioned earlier. Now, let's get into how exactly we use data loggers to develop, these new types of products. So we have to start small. It's easy for us to say, you know what, we'll go in the lab, we'll mix something and then throw it on a building. Well, if you do that, chances are you may waste a lot of product and you're not going to get the results you want because you didn't start small. And just like our concrete project I showed you early on, we looked at the micro scale level and then we scaled it up to where we're actually pouring concrete. This is where we started at with our paint product and our other coating products. So the idea was, what if we were to take a section out of a building? So if you look at a wall section in a residential home, and here in Arizona, it's a lot of stucco construction. You have stucco on the outside, you have some sort of OSB or sheathing, and then you have your insulation, and then on the interior, you have gypsum board and then paint. So if we were to take a 10-inch by 10-inch cutout of that, what we'd want to do is simulate if we were to subject the outside, the stucco side, to some temperature, high, low, we'd want to know what is the temperature profile coming through that section. So we use a thermal testing chamber that's able to cycle through from a temperature down from -20°C all the way up to 60°C. To get accurate results, we need accuracy and temperature measurements. That's critical for us when we're prototyping new materials. And that's ultimately why we need research grade equipment to do just that. So we ended up using MX 1100 series loggers with attached temperature probes, as well as MX 2300 series loggers for more of space temperature readings. So the space temperatures, it's good for measuring the temperature within a wall cavity or within the chamber itself. But with the MX 1100 series, really getting the temperature probe and getting spot measurements, that's ultimately what benefited us to get that profile. And I'll show you a schematic in the next slide. But one thing I really liked about this system is, for us, we need, to get data fast, and both of these come with an app where through Bluetooth we can get it right to our phones, the data. But let's say we're not in the lab, what was nice is we're up in our office and we're able to use the MX gateway, which provides us the data wirelessly. So we just pull it right from the cloud. So it's less for us to worry about the equipment and which one's the best. I mean, these worked extremely well for us and got us the data we needed in exactly the fashion we required. So our sensor locations for prototyping at lab scale, the front view, this is looking at the interior. So the lab temperature was kept constant, and we always run you'll always see two sections, just like our concrete example. You'll have a control, and then you'll have what we're actually testing. And on the side view, on the right side where you see exterior temperature, that's on the inside of that temperature chamber. So if we want to model an Arizona climate, something really hot, then that's where we start. So it's being subjected onto those exterior out sensors. And then immediately on the other side of that layer, we needed temperature so that we can see what the temperature differential was. And then you have interior in and interior out, where once the temperature has been subjected from the outside, what does that look like on the inside? And again, these loggers are able to allow us to get that gradient profile and compare between. And what we really like I said, is the accuracy. I'm talking like less than 0.2 degrees C. And that's something we need because we're looking at a very sophisticated uh, thermal management reduction, and we need to make sure that what we're modeling is what we're finding in these experimental tests. So once the lab scale testing is done and we can understand what that temperature profile looks like coming through the envelope, now we really need to see how does that look at scale. So we developed 2 test building enclosures. These again are located in Casa Grande, Arizona, so it's a hot, dry climate, and they're identical. So again, one serving as the control, the other serving as our test enclosure. Both of them are identical from the construction, from the roof to the walls to the interior. They have identical air conditioners that were individually metered. So lab scale testing is showing us temperature reductions, is showing us how much of a peak shift we can achieve. When we look at the next field scale prototyping, this is showing us what is the energy savings we can expect. Because they're the exact same and have metered air conditioning units, we're able to see what that reduction is. Now, these are about an hour away from our office and our labs, so we needed a way to be able to monitor the data in a remote location. And I should mention that there is no internet here. So what we liked was we used the HOBO Micro RX station, which uses cellular service to collect the data. And with those, we use the RX sensors. And again, like the RX distance is a big thing for the lab scale. I mean, it's all in one chamber, so distance isn't really a problem. But when you start coming out to the field, and these are small field enclosures, but let's say you have like a 1,000,000 square foot manufacturing facility, you're gonna need sensors that can, extend a certain range. So we really like how the RX sensors can go over 1,000 feet. And then for these, we also deployed the 2100 and the 1100 series sensors for the same reasons as the lab scale. We really wanted to understand what is that temperature profile coming through. So here's just a simplified view of the sensor locations. We have the sensors placed on all 4 sides of these enclosures to measure the temperature performance or thermal performance of these different sides. Not just getting the energy savings from the entire enclosure, but what is the difference between, the thermal effect from these different sides so that we can optimize our products for, the specific applications within the envelope. Now our roadmap, lab testing we've done, then we move on to field testing. Now we're in the process of third-party validation with our partners at NREL and getting ASTM testing and certified on our products. And we're looking for industry pilots. So we have one with Arizona State University that I'll talk more about next, and a project with Duke Energy in North Carolina. So these industry pilots are the next stage in our roadmap for commercialization. So we've proved the technology, we understand how much temperature reduction we can achieve, how much energy savings one can expect. Now we want to see what does it look like on an operating building. So just quickly, our pilot project was done on a building at ASU. The building itself was monitored using a building automation system. There was independent thermostats in each room. The airflow and temperature was monitored individually also. They were subjected to the same external environmental conditions. And I must mention the climate also. So this was located in a hot, dry climate. And the reason I keep mentioning climate is because the products, in this case, our elastomeric paint, is tailored specifically for a hot, dry climate. The paint was applied how you'd expect on a roll-on application. And the control product we used was a commercially available reflective roof paint. So anytime we run a control, we always want to run it against what is currently being used. So standard application. And then the results were over a 30% power consumption reduction during those summer months. Because we tailored it for an Arizona climate and the summers here get extremely hot, that is why you see that uptake in reduction. But this paint, it really acts as a thermal barrier all season long. Now, to wrap it up, this is the last section talking about technology impact. We really are looking at decarbonizing buildings because what we believe in is that the cleanest form of energy is one that is not created. So if we can make our buildings more thermally resilient, then you're having to rely on less electricity usage. So our first product, the elastomeric roof paint, we're looking at commercial flat roof buildings as our target markets. Industrial first, because we're located in Arizona and there's a tremendous amount of manufacturing facilities, distribution centers, data centers, all with just large commercial flat roofs. That is where our target is because we believe we can make the biggest impact there. But this technology can go on any number of, I say, flat roofs, but low slope roofs. And ultimately for building owners and operators, we want to help them achieve their ESG goals and reduce their carbon footprint. So the value propositions we offer for thermal performance are, that reduction in peak load, shift in peak load, ultimately reducing electricity consumption, saving money. But for the environment, I mean, you're making an impact by reducing your greenhouse gas emissions. Cool roofs have been a technology that has been used to reduce the urban heat island effect. And what we've developed is the next generation of cool roof, one that performs significantly better and is proven and enhances thermal comfort. That's one that most people don't think of, but in Arizona and with these manufacturing facilities, they don't have, the sophisticated air conditioning equipment that we have in office buildings or even our homes. They're relying more on evaporative cooling. So comfort for the workers inside is huge. Not just comfort, but it's also a safety concern also because temperatures can drastically increase during the summer months. And we've experienced that firsthand by touring manufacturing facilities. And whenever it's 112 outside, it's going to be close to 90, 95 inside. And then again, extending the life of HVAC units because they're not having to operate as often. Now, I appreciate, all of your attention. What we're doing is, we're ultimately helping building owners reduce their operating expenses with a superior, simple, and cost-effective thermal management solution. And I welcome anyone who is interested or would love to be a part of our journey. And with that, I'll take questions. Thank you for your time.
Awesome. Thank you, Dr. Aguayo. We actually do have a question. What sort of roof preparation would one need to complete prior to painting on your product? And in addition to that, about how long or what is the lifespan of the product once it is painted on?
Excellent. So the first part of that question, it's standard with most paints or coatings that you apply to your roof. You need to inspect the roof, ensure that there's no seams that are broken, that would cause leaks. So just proper measures to ensure that all the seams are sealed, all the cracks are filled, and then it power wash so that there's no debris, and then it's just a matter of applying the coating. Now, as how long the coating lasts, it's standard with what's in industry. So typically with these coatings, it's between 10 to 15 years, and that's the same lifespan as ours. The technology that we're integrating into these coatings, it actually exceeds the life of the coating itself. So whenever you apply this coating to your roof, say in year 1, whenever you apply it again in whatever recoating schedule you have planned, you get an additional benefit. So it works even whenever you coat it. Unlike reflective technologies or cool roofs that reflect radiant heat, it relies on the sun's rays to reflect back. But this technology, it works all day long, also during the night. So that's the beauty of it.
Excellent. Thank you so much. And just open it up to see if we have any other questions from anyone else. Otherwise, we will close things out. And thank you for your time today. Really appreciate you joining us and sharing with us how you're using our HOBO data loggers and the excellent research and inventive materials you're coming out with to really help make buildings more energy efficient and kind of combat climate change, which is definitely something on everyone's mind these days.
For sure, for sure. And I appreciate the opportunity to share, our product and technology with you. And please, reach out to us if you have any more questions or would like to know more. Thank you.
Fantastic. All right. Well, thank you so much. And thank you to all of our attendees for joining us today. You can always reach out to any of our application specialists here at Onset Computer to help you with your HOBO data logger needs. If you're trying to select the best data logger for your particular application, we're more than happy to sit down with you, talk through your specific needs, and give you recommendations as to what the best product could be for you. So with that, thank you so much, and we will end the webinar. Everyone have a great afternoon.